All right, so this next one, we want to write a program walks through a folder tree and searches for files with a certain extension. So we'll give it an extension, like PDF or JPEG, and it copies all of these files from whatever location they are in to a new folder. So did you get the impression this was just sitting in the current folder, not going folder inside a folder inside a folder? Just current folder, find all the files and put them into a separate folder? Okay.
Folder tree.
What does it say? Oh, folder tree. It does mean a bunch. Okay. So that means we need to go ahead and I need to create that. So I'm going to go into Documents. And then I'm going to make a folder here called My Files. And inside of My Files, I'm going to touch a dot. We'll just do it with JPEGs here. B, C. And then we'll A.pdf, B.pdf, C.pdf, make directory A, CD, A, D.jpg, make directory B, CD, B, E, something like that. All right, so I've created a directory structure called My Files. Inside of My Files, I have 3 JPEGs, some PDFs or non-JPEG files, and I have a directory in there called A. Inside of there, I have 2 directories, a directory B and a directory C. I have a single JPEG file in B, or in this directory. Then if I CD into B, I now have a single JPEG called E. And then in my C directory, I have a JPEG and a PDF. Does that seem representative of a directory tree with some stuff in it? And maybe our goal here is to move the JPEGs to a single place. All right, so now the idea is to go through the entire tree and bring all of the JPEG files, for example, into a single folder, maybe called found files or something like that. Okay. Folder tree and searches for files with a certain file extension. Copy these files, so not move them, copy them. So make a duplicate of them from wherever location they are in to a new folder. Okay. So let's scroll up here, and again, we're going to solve it similar to what we did in this last one, where we're going to kind of solve at the high level first, then keep adding layer on layer on layer. So let's walk through our tree first. All right, so that's moving files. So I think I actually need to go back to 9 for traversing the tree, right? I think that's where traversing the tree was. Yeah. Files and file paths. All right, so we can go ahead and let's create a folder for our path. What did I call this guy? My files. I think I put this up on Slack already, didn't I? Yep. All right, so we'll call this my files. Is going to be a path called my files, and I happen to put it in the same directory we're currently in, so we have a path coming off of that. We could always read in from the user if we wanted to do that. Right, so let's make a directory, and we might end up doing that because we'll probably want to have a folder to move copies into, but we'll come back to that. Folder contents. So list directory. So we need to import OS. And we'll go ahead and get our list directory from in here just to make sure we're seeing what we're seeing. So we're dealing with our path is my files. I think list directory will work on my files. Print file name. So there's our stuff that's in there. All right, so we're in the right zone now. Okay, so now we want to be able to probably create a maybe directory called like found files, a place to put our stuff. Okay, so we, through our operating system, we also had the ability to, what was that, make directory or something like that. Yeah, so make directory. So we'll go ahead and just say os dot make dirs my files. What is it? Join found file, something like that. I think that will do it. It doesn't have a join. We just have to concatenate onto it. Or I'm just making it in the current directory. All right, so there's my found files, and I think if it runs multiple times, it says file already exists, so we can't create a directory that already exists. So what we might do is, since every single time we run this, we're probably going to be running it with our kind of a new thing to search for. In fact, we might even want to call this guy something kind of cryptic, or because we're kind of taking out the idea that found files is something that we now cannot have a folder named found files in there ourselves, because we created our own file folder called found files. So I can go and delete this beforehand manually, or I can go through this and actually do the error checking for seeing if this guy is there, because we can do a delete as well. So I can say os dot os.ders. Well, for right now, we'll just walk the directory structure. I'll look it up in a second. Okay, so that's how we'll create our directory. We're going to end up putting stuff in there. But this guy right here, and I'll go ahead and just comment this out for right now since we already have that in there. We're now running through and we're seeing our directories. We probably won't do our found files until the very end. Okay, so we want to go through and we want to see all files that follow a certain pattern. Maybe I'm looking for something that ends in a .jpeg, something like this. So we can write a regular expression that asks the question, does this guy follow the pattern of a file of a certain type? For instance, JPEGs. So I can do something like def file match. We'll call this, have this guy take in a file name and call this a extension, ext. And we'll go ahead and we'll say that we'll call this extension match is equal to recompile, and we're looking for anything that ends in a ext So that's what we're looking for, anything that ends in an ext, and maybe we have a period before it. Something like that. Doesn't period match anything?
One character, one anything else.
Yeah, I think it matches one anything, so I can say that. Matches exactly one period followed by that, or we could just match it off the extension and just say, hey, if you want to put a period there, you can put a period there. Call that good enough. All right, so this will say if it ends in this is the end, right? Yeah. So if it ends in this extension, it must match, something like that. So we'll go ahead and we'll say return ext match.search file name not equal to none. So we will search for our file name using our matcher, looking for the extension, and if it is one of those, it would give us something that's not equal to none. It found a match. All right, so this guy will return true if file match for this file name matches this extension type, or false otherwise. So this guy is a Boolean expression. This will boil down to either my matches or none if none were found. So if this is not equal to none, that means that I actually found something. Therefore, this file name does match this extension. Does that make sense? So what I can do now is I can say, I'll print out the file name and then I'll print out file match on my file name, as well as, let's just do a JPEG for my extensions. So now we see like CJPEG is true, BJPEG is true, CPDF is false, AJPEG is true. All right, so we're saying that guy is detecting whether something is a certain kind of file. All right, but this is only at the top level. I need to now be able to tell whether something is a directory or something is a file, right? Because I'm printing out things here. Like, for instance, A is a file name here, but I happen to know A is a directory, correct? Now, I could cheat a little bit and say, well, if I didn't put an extension on it, then it must be a directory, but that's not good enough, right? You know, you can have files that don't have extensions. That's allowed. So we can use the operating system to tell us what kind of file we're dealing with. Drive. What is my check to see if it's A? They can't just give me my little cheat sheet with all my OS stuff. Alright, so that's going to allow us to copy stuff. This will be a good one. Alright, so this allows us with OS to walk an entire tree. So when we say os.walk, we're going to get 3 different things. This is going to return a tuple for us. So here, I'll go back and kind of show this. I'll steal this, and actually we'll steal this whole thing and we'll see it, but we'll talk about tuples again real quick with this. All right, so we have you can tell this guy to walk my files. And we need to indent these things. Will this indent underneath there? Yep. All right, so this os.walk, taking a path, this guy returns a tuple, and a tuple is like a list that is not changeable. So this guy returns a tuple with 3 things in it. The first thing is the name of the folder that you're in, which should be my files. The next thing is a list of subfolders, which should be all the subfolders in that guy, which for us should be our A, and I think I only had A in there, right? Well, it'll find found files right now too. And then all the file names. It'll keep these guys separate. So this allows us to distinguish between folders and file names. So current folder is my files. Subfolder in there is my file, is A, and found files, where found files is going to be an extra thing we do at the end, right? And then inside of my file, so now we can move into that thing and we get all our PDFs, JPEGs, blah, blah, blah. All right. So notice here that we have, this guy has given us the entire list of everything in that directory. Correct? So, and with shutils, I can now copy anything that meets my criteria, right? So for right now, why don't we just go ahead and put something in there maybe called should copy, something like that. because I'm only doing that if I'm dealing with something that is a file name, right? So if I'm inside of a file name, I'm going to ask if, what did I call my thing? File match. If file match for the current file name, given the extension, and we're just going to keep going with our JPEGs for our example here. So if I'm looking at a JPEG, I'll just go ahead and say should copy to collection folder. Just as a quick thing right there. All right, so now when I run this, notice that whenever I'm dealing with a JPEG, it says should copy to collection folder. But if I was dealing with a PDF, for instance, it doesn't say that. So now I've flagged for myself. I know that when I'm in that if statement, that's a file that I want to copy someplace else. Okay? And I probably want to go ahead and give myself a path to where I'm going to copy it to. And just so we don't have the delete issue each time, if you'll allow me to slightly cheat, I'm going to go ahead and get rid of found files. And I'm actually going to just put that up one directory. Found files will just be something that we write there at the very end, one directory up. And actually, if you want to be a little slick with it, we can do something like this. Python get current epoch time function. Is that from import time? Time live. Oh, time. Haha. All right, so this gives us the number of seconds and milliseconds since January 1st, 1970, I think is what Epoch stands for. So we could always create unique directories based on the exact moment that we created the directory. This will allow us to run our program multiple times and always have a most recent found files directory. So I could do something like my output directory is path, and we'll call this guy, actually we need to make the directory, right? I'm going to make it up one directory. So we'll say os dot, what is it, make ders. And make ders takes in the name of the directory as well as where we're going to make it. So the directory we're going to make is going to be called found files, maybe an underscore concatenated with the string version of time.time. So if we come out here and I go up a level, here's our very unique directory that was just created for our found files. All right, so that guy got made, but we want to remember where we're going to be putting that. So in order to do that, I'm going to do this. I have to remember the directory I'm about to make. So I'm going to call it output directory is equal to this. I'll go ahead and make that directory, but I'm also going to go ahead and create a output directory path out of my output directory. That way I can actually write to that guy here in a few minutes. So I remembered the name of the folder once, because the time will change every millisecond. All right, so I remember the name of the folder once. I'll go ahead and make that directory knowing it's going to be unique. This prevents me from having to like check, is a folder there? If so, delete it. Then I'll go ahead and actually give myself a path so I can write to that place in a few minutes. All right. Okay, so now I'm going through all my folders and subfolders, and I hit my file names here, and when I'm inside a certain file name, it's giving me the entire path of that guy, right? Here's the file. So my file's A, B, so this is the, so file inside a folder name slash, where's my slash? Yeah, so folder name gives you the full path of the folder, and then the file itself gives you this guy here. So if I want to, if I should be printing something, or if I should be copying something, I want to get the file I should be copying. All right, so I'll go ahead and say file to copy is equal to, I want to say folder name concatenated with a slash concatenated with the file name. That'll build that full path to the guy that I want to copy. That make sense? So that's the file I'm going to copy. All right, so where is my copy thing? So shutil, I need to import it. I can import it separately, or I can import it with OS. All right, and this guy allows me to copy a path for a file along to the path to the folder I'm going to do it. So this is like a sample string for a path. It allows you to build a path, but I actually have the path stored, so I think I should be able to use sutil copy. So I'll just do this. I'll say shutil dot copy, and what I'm going to copy is the file to copy. Where I'm going to copy is my output directory path. Okay, I went ahead and ran that. If I go out here, I should have a newer thing, which is the new one. The new one's this 4031. Ay, ay, ay. 288458. And there's all my JPEGs in there. That makes sense? So you kind of see, keep in mind the name of the book, Automate the Boring Stuff. Imagine this is kind of a starting point, but if you ever are in a situation where you have a big directory structure with a whole bunch of crap in it and you want to consolidate all your MP3 files or something like that, you can go and try to find the right tools out there on the internet and stuff, or you can just write something like this and make a couple of modifications. That make reasonable sense? All right, so I think that mostly solves that problem. Does it completely solve that problem? I don't remember what it actually asked us to do. Selective copy. Yeah, so I think this is in the spirit of the solution to the problem. All right. So, again, you saw that I kind of did this by just breaking it up into tiny pieces. What do I need to do first? Well, I need to be able to walk my directory structure. Well, how do I do that? Well, let's see if there's something out there so I don't have to invent directory file system walking. So we found this os.walk and gave it the directory we wanted to walk, and it happened to do exactly what we wanted it to do. All right. So I'll go ahead and put that up here. Okay, and that was the last drill for this week, right? And now we have a project. Well, we did one of the projects already. We wrote the regex of strip.
Yes.
Yeah, so now we have to do the filling in the gaps project from the end of chapter 10. Okay. Write a program that finds all the files with a given prefix. So something that starts with a certain something, right? All right. In a single folder and locates any gaps in the numbering, such as if there is a spam 001. So I guess we're just assuming it'll always be some numeric thing. For our example here, it'll be a numeric thing before the extension. Then it will rename all the later files to move forward. I think I saw some globby pattern matching thing in there or something like that that we're probably supposed to use. So I'll go look at that. But let's create our directory structure here real quick. I'll do make dir. We'll call this guy my files 2. All right, and I'll just use their examples. So it's spam 001 text. All right, so we have spam 001.txt. So the touch command in Unix lets me create a file real quick by just touching the file, and it's an empty file that exists, is what it does. All right, so I'll have spam 001, spam 002, spam 004, spam 006. Should be enough. And we ultimately want this to say 1, 2, 3, 4 when all is said and done. All right. So we have a directory that has some stuff in it that does have gaps, and we want to close those gaps. What I'm going to go ahead and do here is for testing, I'm going to go back here. I'm going to do a copy -rf my files 2 to my files 2_back. So I made a backup of that folder in case somewhere along the lines as I'm writing this code and I don't rename them in an appropriate way and I want to go back and start over. I already have my directory structure created in an unbroken way. So usually if you're making stuff like this, work with a copy of the folder you're messing with. All right, so I gave myself my original as a backup in case I break this guy somehow as part of my zigging and zagging. All right, so we'll call this my files 2. So let's get back into here. And we'll use most of the stuff that we had before. Here, I'll go ahead and get rid of some of these things. My directory is called my files 2 in this case. I'm not going to have a output directory. I'm not going to be making a new directory. All right. And I assume, did it say it was going to be a flat directory, or could it say a directory tree? All files in a single folder, okay. So we actually can just go through, instead of walking the entire tree, we can use the file names thing that we had before. So what was it? For file name in my file, was it os dot, what's my walking, just a file directory? Well, that walks the whole folder. Well, I guess it just won't have it'll still work. It won't have subfolders in it, so it won't traverse subfolders. So we'll just use the same thing. All I'm saying is that this is kind of overkill. This will walk a recursive directory, and we've been told here that we actually only have one directory. And that directory is filled up with files. Therefore, we know we're not going to have any subfolders. We're only going to have file names. Not the end of the world. Doesn't make any difference to us, really. We just know that these two things won't even be found. All we care about is our file names and the file names. Yeah, so there was a way to just walk a directory. Wasn't for file name in my files, print file name? We just had it 5 minutes ago. List directory. Isn't that what it's called? os.list directory. There we go. So, simpler, not overkill. This just shows you all the files that are in the current directory. We're assuming they're all files. The other thing would have worked just fine. Just might as well give us a different example here. All right, so here's all of our files in no particular order. And what we want to do is we want to find where we have gaps in here. So let's go back into here, and there's some sort of glob matching thing I think I saw. All right, we're not deleting stuff. There's renaming up here though. Renaming files and folders. So renaming is going to be a move, right? We'll just move it with the same name. Already got that. Where was that glop thing for matching? Wasn't that in... Didn't I see that in here? Wasn't there a... Well, no, I thought there was a matching thing, because we want to get them in a certain order, and I thought I saw a glob. If you want, you can pull that door shut so we don't have to listen to them. screaming while they're playing their video games. Folder. Yeah, modifying a list of files using glob patterns. This is what I was. So if you want to work on specific files, a glob method is simpler to use than list directory for listing the contents of a folder according to a glob pattern. Glob patterns are like a simplified form of regular expressions often used in command line. List from the generator. All right, so for our specific thing, I can use that with our path, right? So I have a path variable that I can use the glob with the path and get a list out of that. So I can do something like, what was inside of, how did I name my files? Spam something. So in case we have all these spam files in there. I can say the list of files is equal to my files dot glob spam star or something like that. And then I can say print the list of files. Oop. Okay, so that gives me my glob stuff. And then I can list from that. Create a list from a glob. And there's my list of files. See if that'll be helpful for us. I don't know if anything left from that's going to be helpful for us. But let me go this route then. I'll just go back to what we... Actually, I'll give myself a list of files here. I'm just going to kind of hack at this. And we'll say the list of files dot append file name. We'll print the list of files. So this should give us a list containing all the files in that directory. Then we're going to say the list of files dot sort. And that will sort the list of files that are in that directory. So now we have a list that's in the right order. This may not be the way that you ended up doing this because I didn't read the whole chapter, obviously. So I'm just hacking at it with the tools that are sitting in front of us. You know, we went to Home Depot. We came home with a bucket of tools. All right, so I made a list out of all the files in the directory. I have a sorted list to have them in the right order. That'll allow me to determine whether or not there are some gaps in there, right? All right. So now, what are some things I can do? I probably want to be able to deal with the last part of these as numerics, right? All right. So I can go ahead and let's assume in our directory structure that we have that all the files start with spam, followed by a number. So it's spam followed by at least one number, followed by a an extension. Okay. So we'll go ahead and let's create a regular expression for this guy. So we're going to call this guy file matcher is equal to re.compile, and we'll give this guy a the pattern for this guy will be, we have spam followed by, actually we're probably just looking for the numbers in here. That's actually probably the, can we just match on the numbers? Because I already know they're all going to have spam in it. If something looks like this, I'd like to be able to work with these guys numerically so I can count through them, right? So if I can get rid of the spam and I can get rid of everything after that, so if I can keep everything that is numeric from a string and replace everything that's not numeric with nothingness, I'll be left with the numbers, right? So if you remember, /D is anything that is a number. /D is everything that's not a number. So we'll call this guy, well, file matcher is fine. And I'm saying I'm looking for things that are not numbers. Any number of not numbers. I want them out of there. All right. Now, this does presume that, because this is a pretty specialized question. It's basically saying, if your files are formatted like this and you happen to have numbers in them, those numbers should count upwards and, without gaps. That's effectively, did you guys read it the same way? I can't have a file named 123 spam 006. The 123 would be illegal for this particular question because I'm specifically looking for files that end in a number. Like when you have counting files like MP3.1, MP3.2, MP3, or for old CDs, track 0, track 1, track 2. All right, so I'm going to break this down so I have something that will allow me to clear out all of the numbers in a string. So I'll go ahead and create a little function called remove numbers, and this guy will take in a list, and I'll steal my file matcher here. Actually, I'll call it number matcher. Call it non-number matcher. All right, and then I'll go ahead and say I'm going to create a new list. Answer is equal to the empty list. And I'll say for val in a list. So for every element in my list, I want to replace all non-numbers with nothing to give me a number. Okay? So what I'll say is answer dot append, and I'm going to say non-number matcher dot sub, and I'm going to substitute nothing for the current value and append that to my answer. Ultimately, I'll return answer. So I'll say just the numbers list is equal to remove numbers, the list of files. Val. This should match.
I think it's the other.
Oh, backslash. Thank you. There we go. All right, so now I have, notice these two lists are the same lists, right? Just the second one has only the numeric parts of those strings. Okay? Now, so what I want to do is I want to get, I think I should be able to get the numeric version of each of those. I want to count through these guys, and anytime I have a gap, so if I go from 0, so I'll start with my very first one. That's my starting number. The next number should be that guy plus 1, right? If it's not, I need to adjust everything from that point forward. So here, we'll just keep doing it out here. So what I'm going to do is I'm going to walk through every element of these two things. So we'll write a little function, define, let's call it fix file names. And this guy will take in list of file names and list of numbers that correspond to it. And I'll go ahead and call fix file names, passing it my list of files and passing it just the numbers. And we'll have him do the logic on that. So inside of here, we'll do something very similar to what we did before. I'm going to go through, I know that these two lists have the same number of things in them, right? They both have the same number of elements in those lists, because I know that the second list here, just the numbers, is this first list with all of the things that are non-numeric removed. Make sense? So I'm going to say for I in range 0 to the length of either one of these guys. List of numbers. So now I want to go ahead and I want to have my starting count. So we're going to say start is equal to, and I'm going to go ahead and say list of numbers. I want the int version of list of numbers at bucket 0. That'll get me my first number that we're dealing with. So I want to just test that real quick. I'll say print start. That should give me a 1 for this guy. Fix file names, fix file name. There's my 1. So give me the numeric version of the 001. All right, because I want these guys to mean, again, the problem we're solving here is the problem that I expect all my files to be in order. With the very first file, when sorted, being the number that I'm starting with. Is that a reasonable assumption? Or do we always want to start it with 1? You can decide which is the problem you're trying to solve. I'm making the assumption here that my starting file will be from the file name that I'm assuming that bucket 0 is already named correctly. If you wanted to start it off at spam 007, that's fine. I'm going to go from 7 to whatever and make sure there's no gaps that point forward. If you want to make sure it starts with 1, that's fine too. You would just do the same logic we're about to do, but make the assumption that start will be 1. Okay? So this is my starting value here. So I'm going to assume that my file number 1, the file at bucket 0, is okay. It's got the right name already. I just want to make sure all the other ones match up. Okay? And if they don't, I need to fix from that value forward. Okay? So I'm going to go ahead and I'm going to say for I in range, I'm going to start at 1 to the length of list of numbers. I'm starting at 1 because I'm assuming that bucket 0 is already cool. He's the right number. Okay? So this will go through all the files starting at bucket 1 through the end, and I'm going to ask the question each time, is the current file number the correct file number? Make sense? If it's not, how much do I need to adjust it by? Keeping in mind that my files are all sorted, right? All right. So we could actually say we can start that guy off at current file num is equal to the integer version of the first one plus 1. If I start off at a 1, the next file I run into should be a 2. That make sense? Because I'm assuming my very first file is okay. So I'm going to go through all my files starting at file 1 through the end. I'm going to ask the question, if list of numbers at bucket I, if the integer version of that guy is equal to current file num, then we're good. But if it's not equal to current file num, I have to fix it, right? So if the current list of numbers value is not equal to the number it should be, I need to fix the number in my original file name and move this file to that file name. So if I'm in here, what does that mean? It means that the file that I'm currently looking at has the wrong number on it. How wrong is the number? Modify is equal to current file num minus the int value of the actual number we're looking at. So let me actually do something here. I'm going to go and print these guys off again just so I can show you examples as we're going through. Oh. All right, so as I go through here, this guy was 001. That's my first one. We're assuming this file name is okay. Then I get to 002. So I get the integer number of 002. Is 2 not equal to 2? That one's okay. If we look at this file, we're going to say this file is okay, right? So each time through this loop, whether we get into this if statement or not, we're going to say current file num plus equals 1. We're going to add 1 to it each time. So it'll take us from file 1 to file 2 to file 3. So we're currently at 3. Is the number 3 equal to a 4? Is it true that the number 3 is not equal to, well, is it true that the number 4 is not equal to the number 3? That's a true statement. Those are different numbers. That means my guy is wrong. His file name is wrong. What is it? Why is his file name wrong? Well, how wrong is it? Well, it's wrong by 3 minus 4. He's off by -1. That makes sense? Okay. Or I could say his name should be this guy. That makes sense? All right. So we need to name the file the correct way. Now, again, we have to make some assumptions here. If you're assuming all your files end in 00 something, are you assuming it's always 3 characters like that? Or are you just going to put the count at the end of it? How do you want to rename your files? That's going to depend on the exact problem you're trying to solve with this. But if we just do something here kind of in the spirit of doing it, I want my file name to change from whatever it currently is in this case, it's currently spam004.txt, to spam00, well, I can say ideally spam003.txt. So I want to substitute the value 4 with the value 3. That's what I want to get out of that, right? So to rename the file, I'm going to substitute a pattern. All right, so I'm going to find the occurrence of 4 in here and substitute it with a 3 to give you my new file name. All right, so I'll go ahead and I'll say file fix is equal to re.compile. And this guy, what am I looking for? I'm looking for the first occurrence of the number 4. Again, we're assuming those are the only numbers in there, right? Okay, so what am I looking for? I'm looking for a, actually we're gonna make this a formatted string. That way I can do this thing in there. And I'm looking for that guy. I think it'll let me do that in a formatted string. Guess we're about to find out. I think I can make a function call in there because it'll boil down to whatever this guy is. So I'm looking for that specific value in a string. That's what I'm looking for. And then I'm going to go ahead and say, I'm going to just print it for right now. I'm going to say replace and we'll say list of file names at bucket I with, we'll say new file name is equal to filefix.sub. And what am I subbing? I'm going to substitute the string version, because we are replacing it with a string, of cur file num. And I'm substituting what? That's what I'm substituting it with. And the thing I'm substituting it in is going to be my list of files names at bucket I. Like that. So that's going to be my new file name. And then I can just say new file name in there. Cur file. Oh, I called it current file num, thanks. File fix. See, I need my spelling checkers. List of file names. Where's the other one?
It should be in the name.
All right, so replace spam4 text with spam3 text, so on and so forth. Replace spam6 with spam4. So those are the moves that we should be making. All right, so that's, I'm going through and checking those. Now I need to actually rename that file. what's my go-to move for renaming a file? That was with the shutils, right?
Yes.
So shutils.move from the original file to the new file. So I actually need to probably be in my here. We'll have this guy taking the file path as well. We'll pass it my files. We'll try to pass it in my files. And we'll go ahead and say, what is it? os dot, or is it shutils dot move, and then it's the source to destination. So the source file is going to be this guy. The destination is going to be this guy. And don't I need to give it my path? Where's the parameter for path? Oh, is it not in? Oh, it was in 10, wasn't it? Oh, I have to give it the full path of the file, but actually we're sitting in that directory. shutils, I do need to move into that directory. I can't do that with a path? All right, well, so the fix is, instead of doing my list directories thing, well, I guess I know what's in my files too. So I can say move my files to / that to my files to / that. I think that should. shutils. Oh, util. One, two, three, four. Let's call it results. That was a pretty ghetto way of going through that, but that was a pretty human way of going through that. Was there a easier way in the book for renaming stuff? I'm assuming there was. I'm asking, when you did that one, was there a less tedious way of doing it, or did you just have to go through one at a time like that? Yeah, so, I mean, I'm just thinking from the perspective of, you know, in order to get the things ordered right to find those gaps, my gut feeling is there might be a file directory tool that does something like that, but because I wasn't familiar with the tool necessarily, I'll flip through the book to see if there was something, and I'll post something up on Slack if there was. I just decided, okay, well, what are the tools sitting in front of me? Let me pull it out into a list. let me use my regular instructions to get the pieces of it that are important to me, and then I can sort it and then work with those things on there. So I got the information I knew how to get from the directory structure and then did the rest with just logic. That makes sense? So this is a pretty, not necessarily a bad way, just a very step-by-step way. Here's my files, get them sorted. Now I have an order, get the number version of the order, find out which numbers are missing, and fix file names. Okay, I'll put this up there for next week. There is the next group of things are due, which are from the next things in the chapter. When I'm looking at this tonight, actually, it won't be tonight. When I'm looking at to see if there was a better solution for this, probably tomorrow afternoon sometime, I'll post up if there's a better solution. But I'll also go ahead and look through at the next assignments and flip through the book at the same time, because they're going to start getting harder and harder. So I'll push you in the right direction for each one if there's a zig instead of a zag. All right, maybe I'll give you a couple of sentences on how I might do it to give you a little paint by number. Questions, comments, concerns, bribes. All right, I will see everybody on what day of the week is this? Wednesday.